A few comments on the homework. Section 13.4 Green's theorem. On number 6, observe the result is just seven times the area of the ellipse. And you want to kind of notice these things as you go, and you probably didn't put it into the problem. But as you're doing them, it helps give you a deeper insight, a more geometric insight. And on number 15, of course, the result's going to be equal to the area of the ellipse, which is easily verified. On number 16, you did the right thing. You did the integral. You can also observe that there's a symmetry in that expression, 2x minus 2y. Okay? In the first and third quadrants, you have an asymmetry. Replace x by negative x, y by negative y. You get the negative. And the same with the second and fourth. Okay. On number 21, let's see, what did I wrote these last night. You can use the integral over the entire boundary to conclude what the integral over just C2 is. Of course, that would be straightforward enough just to set up. But again, something else useful. Often, if you can get the integral around a path, then if you know the integral over part of that path but not the other part, you can conclude the integral over that other part using Green's theorem. And that becomes really, you have this thing called contour integration in complex analysis. It has very much similar flavor. On number 22, I made a note. I just said that the negative 15 pi over 2 is the magnitude, that's the right magnitude, is 5 times the magnitude of the area of the cardioid. And it follows that the area of the cardioid turns out to be 3/2 the area of the circle that I sketched, and that would be a circle of radius 2 centered at the point 0, 1. Let's see what else. Still got a question on number 26. Have to look at that again. I just want to see if there's a deeper insight to be gained there. I think what you did is right. And, is there a geometric interpretation for number 32? And I might well do a video on that. Number 37, what you have there is something very close to the Cauchy-Riemann equations, and I might well do a video on that. For the complex derivative, if a function has a complex derivative, then the ux would be equal to the negative of the vy. That's called the Cauchy-Riemann equation. Maybe could be regarded as the first important result in complex analysis. Okay, I want to look a little bit more at number 38. Something there doesn't seem to gel, but I didn't have time to think that through very carefully. So, looking very good. Hopefully I'll come up with something interesting in a couple more of these problems and do a couple of videos.